Section 10.3 is about ellipses. So we talked about parabolas in the last section, and now we're going to talk about the second type of conic section called an ellipse. And an ellipse is defined as followed. An ellipse is the set of all points x and y in a plane, the sum of whose distances from two distinct fixed points, called the foci, which is the plural of focus, is constant. So in other words, we have two distances here. Let's just focus on, pun partially intended, D1 and D2. If I were to draw another point over, I don't know, here, and connect these, each focus to that, let's call that, sorry, I pressed the wrong button. Let's call that D3 and D4. Then D1 plus D2 would be equal to D3 plus D4. You can do that for any given point. So you could also do one, I'm not going to draw it exactly on the horizontal there, but let's say we have a point here, or a segment there and a segment there. Call it D5 and D6. And so this would also be equal to D5 plus D6. So the sum of the distances between the point and each of the two foci, each focus, is constant. Now the line through the foci, through the foci intersects the ellipse at 2 points, and we call these points vertices. So identifying that's a vertex right there. That's the vertices is the plural of vertex. And on the right side we also have a vertex. Now the chord or the segment joining the two vertices is our major axis. So that wider one there is the major axis. And its midpoint is the center. Well, that's just something we don't even need to bother labeling. Now the chord perpendicular to the major axis going through the center is our minor axis. So we have a major axis and a minor axis. Now the standard equation to come up with an ellipse, and it all kind of depends on whether you're dealing with a horizontal or vertical major axis, just kind of like we had a horizontal and vertical axis for our parabolas. So we got the standard form of the equation of the parabola with center at hk and the major and minor axis of 2a and 2b respectively. In other words, this whole length right here is 2a, which means like half of it would be a. And then for the minor axis, the whole thing is 2b, which means half of it would just be 1b. So it's going to be x minus h squared over a squared plus y minus k squared over b squared. Now we dealt with x minus h, sorry, that whole thing equal to 1. We dealt with x minus h and y minus k last time. One other thing about this time, like with the parabolas, only one group was squared. In this case, both the x minus h squared, or is squared, and the y minus k is also squared. Now that's also closely related to the equation for a circle. Oh, CIR. The equation for a circle is y minus h squared plus, I don't know why I flipped it around in my head, sorry, x minus h plus y minus k squared equals r squared with the center at the coordinate h comma k. In this case, it's very, very similar. We still have the x minus h squared, we still have the y minus k squared, but in this case, both the x minus h and the y minus k are both being divided by a squared and b squared, respectively. And they're also not equal to r squared, they're equal to just 1. Now, for a major horizontal axis that's vertical, that'd be kind of like a taller, skinnier ellipse. It's still x minus h squared over b squared plus y minus k squared over a squared. So really the denominators are the parts that are changing points. And that's again for a vertical minor axis or major axis. Now the foci lies in the minor or major axis, my apologies, and there are c units from the center. And with c squared equal to a squared minus b squared. So it's really closely, like it's similar to how we write the Pythagorean theorem, but that would be a squared plus b squared. This one's a squared minus b squared. Now, if the center of the origin is at 0, 0, then the equation just takes one of the following forms. Essentially, we just get rid of the minus h and the minus k. It just ends up with x squared over a squared plus y squared over b squared equals 1, and that's for horizontal, and then it's x squared over b squared plus y squared over a squared equals 1. Now, taking a look at, oops, sorry, I was trying to scroll down with my mouse on there, but I need to go on my iPad. taking a look at these two equations here, or these two graphs here. We've got a horizontal major axis and a vertical major axis. Now this is going to help us put things into perspective. The equation for the horizontal major axis, that was the x minus h squared over a squared plus y minus k squared over b squared equals 0. Now, labeling a couple of things here. Again, this length here, half the major axis is a, and therefore the other half is also a. The whole thing, you got it labeled down here, is 2a. Now, for the vertical axis, we got half of it's b, half it's b. In other words, the whole thing is 2b. Now, for the vertical major axis, we're doing x minus h squared over b squared plus y minus k squared over a squared. So essentially, the a just goes along with whether it's vertical or horizontal. The a squared goes with the horizontal, the x minus h component, if it's a horizontal axis. And the a squared goes with y minus k on a vertical axis. So we've got a longer vertical axis, so that's all of 2a, and the minor axis is our horizontal axis in this case. For example 1, we're asked to find the standard form of the equation with the ellipse having foci at 0, 1, and 4, 1, and the major axis length of 6. So looking at this, the y coordinates are the same. The y coordinates are always going to be, so that's going to indicate whether or not we have a vertical or horizontal major axis. Since the y coordinates are the same, that means they're on the same horizontal line. So it's going to be a horizontal major axis. Let's draw these out. So at 0, 1, we have one of our points. That is one of our foci, a focus, if you will. And then we have another point at 4, 1, so we'll go 4 over, and we'll draw another focus there. And I'm just going to label those with F's for focus, just kind of like we had a focus for a parabola. The center is going to just be halfway between those two. So the center is going to be here at 2, 1. And that's our center. Now, the major axis length is 6. 6 is going to be equal to 2 times a. You'll notice, regardless of whether you're dealing with a vertical or horizontal major axis, the whole length is always described as 2a, whether it's a horizontal or it's a vertical. So that's going to help us solve for a couple things here. So 6 equals 2a. In other words, a equals 3. Again, we already labeled it. Our center is at 2, 1, and we have a decent amount of information here. Now, the other piece of information we don't have quite yet is where our vertex is, or where our vertices are, and what our what our c value is. We need to use the equation c squared equals a squared minus b squared to find all of our information. So the c squared is just the distance from the center to the focus. So the distance from the center to the focus in this case is just 2. So our c value is 2. So we have 2 squared equals our a value was 3. 3 squared minus b squared. So we got 4 equals 9 minus b squared. Don't know what b squared is yet. So to solve for b squared, we'll subtract 9 from both sides, and we get negative 5 equals negative b squared. Well, let's just clear that up a second. That makes it positive 5 equals b squared. And then we're going to take the square root of both sides. And the square root of 5 is, well, that's just the square root of 5. And that's going to be equal to our b value. Now, quick reminder, whenever we insert a square root in order to solve for a variable in an equation, we should get a positive or negative, or positive and negative outcome. Since we're dealing exclusively with distances here, we're just going to focus on the positive outcome. Okay, now we've got a bunch of information here. We can start writing our equation. We have x minus h squared over a squared plus y minus k squared over b squared equals 1. Now the h and the k, we did not label those yet, but we can find those pretty quickly because the h and the k are just the x and y coordinates of our center. So we have, x minus 2 squared over our a value is 3, so a squared is going to be, well, I'll just write 3 squared. We'll just take another step. Plus y minus k squared, we know the k value. The k value is 1. So we have y minus 1 squared over our b value, which was the square root of 5, and that is being squared. equals 1. Now, thankfully, that denominator, let me zoom in a little bit, that square root of 5 squared does clean up nicely. So our final standard form of this equation is x minus h squared over 9 plus y minus 1 squared, and then the square root of 5 squared is just positive 5 equals 1. So that is our equation for this, the standard form of this equation. Now, another thing that we didn't really have to find for this one is the major axis length is 6. Now, right now, this distance is 4 along that major axis. So if we go one more in this direction and one more in this direction, you can find a vertex. That's not, or we're not asked to draw the whole thing right now, but that's going to come in handy in a little bit.